Hello. So today we are going to discuss some interview questions that you might be asked. So what is inside a solar photovoltaic panel? That may be the question. So this is a picture. It shows a solar panel on the top of my inset, and in the left, in the your right, you can see there is a frame. There are some string interconnects. There are some front sheet, encapsulant, and back sheet, and also inside we have some silicon cells. Now, what are these things? We need to visualize from this panel. This is a panel that I use for my experiments. Now, the frame that you can see that is also in this image, that is the frame made of aluminium alloy. The benefit of aluminium is it is an excellent conductor. So when the temperature rises in the solar panel, it dissipates that heat very quickly. That is one benefit. Another benefit is aluminium is durable, yet it is lightweight compared to steel. And also there are other good conductors, other thermal conductors also. For example, we can have copper, but copper will be expensive, and copper is not as hard as aluminium, as good as aluminium. So aluminium foam is used. And the front sheet that you can see here, the front sheet is made of glass, and inside this there will be an encapsulant layer which is essentially a glue, and inside that there will be some crystalline silicon. And why I am calling this crystalline silicon, I will explain this in the next sheet. And also you can see here, here you have some conductor leads that come from the string interconnects, and that goes to the junction box, and from junction box we can have different values, with different outputs. For example, if you see the back side of this panel, in the back side we have two things. You can see the positive and negative, and also other things are also there, and this is the back sheet, that is the white color. Now if we look at the monocrystalline and polycrystalline cell, the C, in the previous slide we saw CSI. SI means it is made of silicon, and C, the value of C means it is crystalline. Now there can be two kind of cell. The cell that I am holding here, you can see it is bluish. It is bluish. So it is a polycrystalline cell. From the color difference you can understand, and another difference is texture difference. As you can see, the monocrystalline, that is made from one particular bar. It is a monolithic cell. For example, the silicon, consider it like a chocolate, and it is made in different small slices, very thin slices, like 100 of these cells. If you stack them one above another, that will be 1 centimeter thick. So that much light it is, that much fine it is. And after that, when the monocrystalline cells are produced, there will be some scraps, there will be some extra parts. Also, when you recycle this kind of panels, there will be some extra silicons. So when you melt them all together and produces some another such silicon cells, that becomes polycrystalline panels. Now monocrystalline panels has higher efficiency, it can be between 15 to 25, and polycrystalline efficiency is below 15. For example, the panel that I have shown you, the efficiency is written here, it is how much, it is 11.9%. So that is less. And monocrystalline has other benefits also. When the photovoltaic cells get hot, the efficiency is decreased. So in case of polycrystalline, the efficiency is much decreased, and monocrystalline, the efficiency is slightly less decreased. The rate of decrease of efficiency with respect to temperature, that is different in two cases. Now, how to connect those cells in electrically? So, first of all, the cell that I have shown here, the top part that faces the sun, that is negative, and the bottom part, that is positive, and each cell act as current source. Yes, it is a current source, but not an ideal current source. It is a light dependent current source that also depends on the operating point of the photovoltaic, that is the what is the voltage across it. So it has to collect the current from the top cell, and it goes to the next cell. It is like a stitching like arrangement. So consider these two are cells. The top part will be connected to the bottom part of the next cell, as I have shown in the previous slide, in the first slide. Now you can see there are two kind of conductors here. One is the bus bar, that is the larger current collector, and for each cell, and within the cells there will be some small finger like current collectors. Now when these cells are designed, two things have to be kept in mind. One is, if our conductors are very thin, that means their resistance will be high. On the other hand, when our conductors are not very thin, they are spread. In that case, the electrical resistance will be less, that is good, but at the same time, it will block some light. So the efficiency will be decreased. So when they are designed, it has to be very much optimized. That is one thing. And apart from this, there are two kind of materials used here. The thinner values, that fingers, that are made of higher conductive material such as silver, Ag. Now all we know that silver is very expensive, so the bigger bus bars, they are not generally made with silver, they are made with copper wire. And we know copper wire is actually, it is brownish in color, brown color. So the copper wire roll that you can see in the side, that is PV ribbon, it is actually tin. It means there are some solder iron that is melted and coated over the flat copper wire, and things are kept flat because all the things are laminated. It is like the solar panel works like a sandwich. It is made like a sandwich. First you have some glass, and then you have some encapsulant that holds all these solar panels, whole solar cells, and all the wires, and then we have a back sheet, and all these things are clubbed together and surrounded by a frame, aluminium frame, that I have shown previously. Now I have said there will be glass. Now what kind of glass are used? Now there can be many kind of glass, or many kind of polymers also. Nowadays polymers are coming, but traditionally glass is the used in most cases, and it is written in every manual or every manufacturing document that it has to be low iron glass. Why it is visible from this image that I have taken from a glass manufacturer website? What they have showed is, when we make glass, we actually melt sands, and sand or any material that is abundant in earth, it has some iron content, iron oxide, ferrous oxide, ferric oxide, such things. When we have such oxides, the glass becomes a little bit greenish, or some color is there. And when a glass is more colored, it means the optical transmission ratio of that is reduced. So you can see, when we have some bulletproof glass or something like that, or even the household furnitures that have some thick glasses, they, from the side, they look greenish. But in solar panels, the solar cells are right under those glasses, so it has to have higher optical transmission. That is why we use low iron glass. And apart from this, because of less number of impurity, the chances of cracking, thermal cracking, that is also less in low iron glass. In India, there is a manufacturer who makes this solar PV grade glass, that is called Borosil. Borosil company makes such glasses. Now we come to the encapsulant. As I said, encapsulant is nothing but a glue, and the material that is used is ethylene vinyl acetate, EVA. Short form is EVA, and as you can see from the picture, it is a hydrocarbon. It is made of hydrocarbon, and it is a cross-linking polymer. So it holds all these things: glass, cell, conductor, and bed sheet layer. And this layer is also has to be optically transparent, because the cell is completely covered with it, and light should be going through it. And the backsheet is the lower layer of the PV module, that is this white layer, that is backsheet. Typically the commercial name of this backsheet that is used here, that is Tedlar, and it is the lower part of the PV module. It protects the electrical parts from moisture ingress. Now the solar cells that I have shown here, they are very vulnerable, and when moisture goes inside those solar cells, the performance will degrade, and the solar cells will be bad after some 10 to 15 years.